Hey everyone, in this video I'm just going to review a bunch of topics. Actually, for this one I'm going to review something called angle relationships. And if you see this, this is from classwork that we've gave to our students. So this one is about angle relationships. This one is about parallel and perpendicular lines. So I'm going to create a set of videos focusing on these topics specifically. And these are all Regents questions, so let's get started. So for this one, it says in the diagram below, line AEFB is parallel to line CGD, right? So they have our diagrams here, and GE and GF are drawn, right? So GE is here, GF is drawn here. So it says if measure angle EFG, so EFG is here, is equals 32 degrees, and measure angle AEG is 137 degrees, so AEG is here. What is the measure of angle EGF? Right here. Okay, now there are several ways of approaching this. So I'm going to try and go through at least two of the ways. So the first way, which one of my students, the first way you can do this is by remembering that if you have a triangle and you have two interior angles and an exterior angle, a non-adjacent exterior angles, and non-adjacent means that the angles don't touch, the interior angles don't touch this exterior angle, then you can use the formula, the sum of the two non-adjacent interior angles is equal to that exterior angle, and you can figure out any of these three angles given that you already have the other two. So we're actually in that situation where this is an interior angle in this triangle, this is another interior angle, and this is the exterior angle, this is the non-adjacent exterior angle. So we can say 32 plus x equals 137, right? And just use your calculator. Subtract, if you need to, subtract 32 on both sides. Okay, 137 minus 32 is going to be x equals 105. And that's going to be our value for here, 105. Now, let's say you didn't remember this formula. How could you have gone about solving this problem? So let me erase these. And let's see. Well, I know that when two angles are next to each other on the same straight line, they add to 180. So I can say, okay, well, what plus 137 gives you 180? You can just go into the calculator and do 180. Let me actually write this down too so I can list out the steps that are happening. 180 minus 137. You get 43. So you can put 43 degrees here. Now, we have two angles in our triangle. All the angles in a triangle add up to 180. So knowing that, we can say 43 plus 32 plus x equals 180. Combine like terms, we have 43 plus 32. Okay, we have 75 plus x equals 180. Subtract both sides by 75, and we get 105 again. So there are multiple ways to approach this problem. As long as you choose a way that makes the most sense to you, you're going to get your answer. So that's pretty much it for the first one. Let's move on to the second one. Okay, so here it says in the diagram below, lines N and M are cut by transversals P and Q. Okay, and then it says what value of x would make the lines N and M parallel. Now, you want to keep in mind that whenever you're proving two lines are parallel, you're either going to show that you have a pair of corresponding angles, you either have a pair of alternate interior or alternate exterior angles, you either have a pair of same side interior or exterior angles. So one of these five, right? 1, 2, 3, 4, 5. One of these five angle pairs needs to show up on this diagram to prove that you have two lines, at least two lines that are parallel. So let's start filling stuff out. I don't have much information in this triangle I see here to figure out what x is, so I need to figure out some more information given these two angles. Now, I know that when two lines intersect, right, lines N and M are cut by transversals, that means they're being intersected. I have vertical angles forming. So what are vertical angles? Those are angles that when they're across from each other, they're congruent. So if 80 is up here, 80 is also down here. If 30 is here, 30 is also here. Okay. What I am noticing is, let's see. Oh, not what I'm noticing. So what I can do also is try and figure out, let's see, this angle here. So again, I know angles on a straight line at 180, so I can mark this as like x for now. Well, not x, this is already used x, so I'll mark it as y. And I can just do y plus 80 plus 30 equals, so add 80 and 30, I have y plus 110, and then equals 180. Oh, this is why my equation is not looking right. I'm like writing this, I'm like, what's going on? Sorry, this is all supposed to be equal to 180 because they're on the same straight line. So we have y plus 110 equals 180. We're going to subtract 110 on both sides. We have y equals 70. All right, great. So let's see. We have a 70 here, and we have a 70 here. All right, that's pretty much good to go. Let's see what we can do, because we only have so much information. We know that we have a bunch of transversals. Let's see. If we, and this is what we gotta keep in mind. We're trying to prove something parallel. So if we assume that if this is 30, then this could also be 30, right? Under the assumption that these are alternate interior angles, we can put a 30 here, and now we have two angles in a triangle. And as we know from a previous problem, angles in a triangle add up to 180. So we can do 30 plus 80 plus x equals, then we could just do 30 plus 80, which is 110, plus x equals 180, and then x equals 70, right? So that means that in order for these two lines to be parallel, we definitely need x to be 70. Now, with this problem, even though you're trying to prove something is parallel, you can assume that these lines are parallel to see if it actually works out. And that'll help you get your answer. Otherwise, you won't be able to progress. You know, as you see, I paused up here. I'm like, how can I get this information down here? Well, the only way I can proceed is to already assume that these two are parallel. I just need to algebraically show that that's true. So with that being said, you're pretty much done with this problem. And you just need to remember these 5 angle pairs whenever you're dealing with showing angles that are parallel or whatnot. Okay, so let's move on to the next one. So, as shown in the diagram below, lines M and N are cut by transversal, okay? Then it says, if measure angle 1 is 4x plus 14, so 4x plus 14 is here. Sorry, let me bring that into camera. And then measure angle 2 is 8x plus 10 here. Lines M and M are parallel when x equals. So this is another example of we have to assume that these two lines are parallel, and by assuming that, then we can start working with equations and figuring out which x value is going to work to actually prove that these lines are parallel. So under this assumption, we already have our 5 angle properties. Now, these are not alternate interior angles because even though the angle 1 is in between the two lines, angle 2 is not. These are not alternate exterior because same logic, even though angle 2 is outside of the two lines, angle 1 is not. So that means that they don't have a congruent relationship. They must have a supplementary relationship because those are the only two choices we have when it comes to parallel lines. Now, if it has a supplementary relationship, how do we see that? Well, assuming that these two lines are parallel, I can say that if angle 2 is here, its corresponding angle is up here, right? They're both in the lower right region of the four parts of the line. So that means if 8x plus 10 is here, 8x plus 10 is also here. Now, if they're next to each other on a straight line, that means they're supplementary. Supplementary angles always add to 180. So you're going to do 4x plus 14 plus 8x plus 10 equals 180 degrees. And then this is a normal equation to solve. So 4x plus 8x, that's going to be 12x. 14 plus 10 is going to be 24, equals 180. You're going to do 180 minus 24 on both sides. So minus 24, minus 24. We have 12x equals 156. You're going to divide by 12 on both sides. Divide by 12, divide by 12. X equals 13. Our question is asking us what value could x be in order to prove that these are parallel. That would have to be 13. Alright, and that was pretty much it. Let's go to the next one. So it says, as shown in the diagram below, we have ABC is parallel to EFG. So you can automatically assume your alternate interior, corresponding angles, whatever. And it says BF, mark this in red, BF is congruent to EF. Right? So because of that, this triangle is now what we call an isosceles triangle. That means that not only two sides are congruent, but two angles are congruent. So let's keep that in mind. So if measure angle CBF, so CBF is 42.5 degrees, then measure angle EBF, so EBF, so this is our x, is what? Alright, so let's see. Now, I know that because I have two parallel lines, if this is 42.5, then this is also 42.5 by alternate interior angles. So let me just mark that. Okay. Now, because this is an isosceles triangle, and I know two angles are congruent, the way I can determine which two angles are congruent is by looking at the direction, I'm going to mark these hash marks with arrows, but just by looking at the direction as where the arrows are pointing to. So this arrow is pointing to this angle, so that means this angle is going to be congruent to this angle. Okay, and you see that I note that I marked it with different type of hash marks, right? Because I don't know if these angles are going to be the same as this one. So because these two angles are congruent, if this is x, I can also mark this as x. And then we go back to basics. We say we have a triangle. The angles in a triangle add up to 180 degrees. So I write that equation. I have x plus x, so x plus 42.5 equals 180. 2x plus 42.5 equals 180. And then you just proceed as normal, 180 minus 42.5, so minus 42.5 on both sides. I have 2x equals 137.5. You're going to divide by 2 on both sides. X equals 68.75 degrees. And that will be our answer for this one. So that was pretty much it for Station 1. If you have any questions or comments, leave them in the comment section below, like and subscribe, and share the video. Bye!